Hey guys, we have an LG washing machine very graciously donated by my boss. Thank you, Joe. It's an LG. It's a direct drive motor. It is, let's see if we can get a look at the model number. WT1101CW. Looks like it's in pretty good shape overall. But he got rid of this and donated it to Joe's garage because of this. So I'm going to plug it in and turn it on. You guys listen carefully. So I'm plugging it in. It's now plugged in. All I'm going to do is going to press the power button. Hear that humming sound? That is the wash motor running. Why is it running? Got me. Turn it off. Still running. Let's dig in and see what's going on. Full disclosure, I have never worked on one of these washing machines. I have a pretty good idea of what the problem might be. But please forgive me if I'm approaching this wrong or pros are watching and calling me expletives in the comments. I think it's a control board problem. And I believe the control board is probably under here. That might be the most logical place to put it. So let's see if we can pop this cover off gently. So there's some screws buried under here. Little caps on either side. Open them gently so as not to damage them. This looks like a pretty fancy washing machine. He got a new one. He didn't really feel like dealing with it. I don't blame him. I think he had a tech come over too, and I think he may have confirmed it's a control board. Not that I cheated. I can tell just by the sound of it it's a control board. Just thinking about it logically, I'll tell you why I think it's a control board. Because you turn the machine on, right? You tell it to fill with water, or here we just turned it on. We didn't even tell it to fill with water. What actuates the wash motor? The wash motor is turned on by something. The wash motor is turned on by the control board. So I'm guessing we're going to find that we either have a failed MOSFET or IGBT on the control board, which is one of those like solid state relay things, or we might have welded relay contacts. So I'm guessing, and this is purely a guess, this might be a pretty inexpensive fix. Not necessarily an easy one, but inexpensive. So I'm going to venture a guess that all we have to do is replace a 9-cent component and we might be back in business. Could be wrong. This thing might be junk. If it needs a whole new control board, it probably will be junk. But I think it's worth a try nonetheless, because again, it looks like a pretty nice machine. It's in reasonably good shape. Of course, half the battle with these things is figuring out how to get them apart. 65-mile long bolts. Let's see, does this just pop up now? Maybe my guess about where the control board is located was wrong. Interesting. Okay, so maybe not there. I do see some screws in the back here. And yes, I am just guessing. Taking educated guesses about where stuff might be. Let's take this back cover off. Maybe the control board's buried under here. Of course, nothing wants to come apart. Man, nothing is ever easy anymore. Remember when these things used to be made out of like cast iron and indestructible? Not so much anymore, huh? So what's holding this? It's just a couple of clips. I don't see any screws. Maybe I need to look at someone else's YouTube channel and figure out how to get this thing apart. All right, enough talking. Okay, I looked at a parts diagram. I think I've been approaching this all wrong. I didn't need to take out these screws in the back. I had it right the first time. Just take out those two long ones in the front, and that control panel should just slide to one side, I believe. I could be wrong. I'm just looking at the parts diagram and kind of reading between the lines. Again, I probably could look at someone else's YouTube channel, but what's the fun in that, right? Oh, look at that. Maybe I was right. Okay, neato. Hopefully someone tried to beat on that. So again, I think we're going to find a problem with the control board. It may not be apparent initially, but let's see what we see. It's about 12 billion screws that hold this thing on. Do we need to take those off? Yeah, it looks like we do. My boss was saying this thing has Wi-Fi. I don't see that anywhere yet. But when we get a look at the control board, we might see that. We'll probably see an RF antenna and maybe some other cool stuff, right? Okay, so maybe it wasn't a billion screws, but it was close to it. There's one on this side. Is there one on, yeah, there's one on either side. So you have a total of, let's see, 1, 2, 3, 4, 5, 6 screws. I think this thing should pop out now. Maybe? I don't know. Guys, I don't really know what I'm doing. I just fake it poorly. It kind of smells like someone's been smoking around this thing. Make sure you drop all the fasteners too. That's really important. And if this is your personal washing machine, it's your main washing machine, you might want to let your significant other go out for lunch or something. Might be a little scary. This does look like a really nice washing machine though. I'll have to ask him if he likes the replacement, if it's any better, or hopefully it works. Last one, hopefully. Okay, so there's our heavily potted display, which is a good thing. Hopefully our troublesome component isn't potted in here. So there we go. So all this stuff here is goo to prevent water from getting in here. Does this just pop off? Yeah, okay, so everything hopefully will just come out of here. Just kind of work it with your fingernails. Carefully. Don't break a fingernail. That would be bad. Don't break the board either. That'd be equally bad. Okay, so all the clips on that side are done. There's a couple on the other side. Okay. Maybe I didn't have to unscrew all that. Oh, geez. This is very, very heavily coated. Replacing components might be very difficult. So let's see what we see here. So I'm guessing this is probably power coming in. Just by the wires. You got 3 wires there, probably a hot, a neutral, and a ground. Again, just guessing. Maybe this, oh no, I'm sorry. Incoming power is over here. That makes more sense. So if you're hot, your neutral, and a ground. You have, this might be some kind of transformer. I see there's a little transformer over here. See a fuse down in there. Man, this thing's really heavily coated. That's gonna be tough to fix. I don't see any signs this thing has Wi-Fi. Unless all that's buried under this heatsink. I also don't see many relays either. So I see, boy, I can't even tell. So we got our power, fuse, got some filter caps. Maybe all the fun stuff's on the reverse side of the board. I've had some time to ponder. So I'm guessing that these are probably the drivers for the direct drive motor on the bottom of the unit. That's probably a high current unit. And I see these little itty bitty relays buried in here. Relay 1, relay 2. I'm guessing that's probably where our problem is. Let me try giving this thing power. Hopefully not electrocuting myself in the process. Let's tap those relays and see if something good happens. Okay. Oh, here it just stopped. I was after banging on this thing. Maybe that's a relay. Interesting. It's probably a little bit easier to get to. Let's turn it off and on again and see what happens. Pulling the power. Let it die out. There's a little LED down there. Oh, LED's out. Plug it in again. Turn it on again. Interesting. So now it's okay. But I'm guessing we have a piece of crap relay right here. Next question is, how do you replace that thing? When they coat these boards with all this goo to prevent water and people like us from getting in there, also makes servicing them almost impossible. This stuff is like an epoxy almost. I mean, it's soft, but it's not, not something you can easily get through without cutting and potentially further damage. I'm not even sure we can get the board out of here because we have to go on the opposite side to service that thing. All right, enough messing around. Let's get to work. Now is a great time to take note of where everything goes and the orientation. This is mostly for my benefit, not yours, since I'm the one that has to put this thing back together. So we see a red connector there. There are the wires. Another red connector over here. I suspect these things are really only long enough to go in one spot. And a lot of them are probably keyed to only go in one direction. It's probably the motor drive. These guys down here are a bit different. You got black all the way to green, black all the way to yellow. There are a couple connectors there that can't really see any colors on them. I don't know, whatever. Let's just start disconnecting stuff and see what happens. How bad could it get, right? So let's disconnect our power in just a moment. Some of these might have positive retention. Really tough to tell. That one did not, just a little clip. That was pretty easy. Jeez. Need tiny hands to work on these things. Or a screwdriver. There we go. Get you guys out of the way. So these all have positive retention, but when I said positive retention before, I misspoke. Some connectors, especially in the automotive world, have two forms of positive retention. They'll have a clip and they'll have a retainer that keeps the clip from popping out. Thankfully, none of these have that. These are all pretty straightforward. They are positively retained, but they are positively retained without being super annoying. go. Got one up here. And just to be clear, I'm expecting a huge fight from this potting material. It looks like to be some kind of silicone variety. So here we have, I don't think I got a good picture of this. We got some, so we have 2 blue connectors. Oh, they're different sizes. Doesn't really matter then. That means they only go in one spot. One. Two. All right, I think the board is now free of its harness. Looks like the board and the LED separate. I see some clips here, so let's see if we can further separate it. Maybe they'll be, maybe the back of the board will be bare. I don't think we'll get that lucky. Fantastic if it was, though. Let's take it over the bench. There we go, the familiar workbench. Man, this thing is on there tight. There are latches, yeah, there are connectors on both sides. Man, these things are no joke. Okay, I fought the battle and I won. Looks like we still have one connector over here though. Yeah, so we just gotta yank this out. It comes across between these 2 connectors, flips around, then goes into the LC. I guess the display board, which is here. So this is our board that has a problem, and unfortunately the bottom is covered. So I'm not really sure how much luck we're going to have with this. This coating does seem to be pretty intense. We kind of need to get this whole board out too, because we need to get the reverse side. I wonder if I could just kind of work around the edges like this for 12 or 13 hours. Now this stuff doesn't seem to be the type of potting material that hardens and is designed to protect intellectual property. It's like a silicone almost. At least it feels like. I don't know what it actually is. Just kind of working around the edge. I don't know if this is going to work. I got nothing to lose though. Washing machine's no good. It doesn't fill with water. Not sure how effective prying the potting material away from the plastic is, or how effective that's going to be. Primarily because I think the potting material is actually under the board. So I think I'm going to have to either use a heat gun and soften it, if it even gets soft. I don't know. That's what she said. Or I might actually have to cut out a piece behind here. That might be the safest approach. Let me try a heat gun on this side of the board that's less populated and just see if it does anything really. That stuff is no joke. The plastic enclosure was actually melting. That's crazy. All right, plan B. I think we're going to take a razor knife and just cut out a piece of plastic here. A little unorthodox, but I don't really know what else to try at this point. This stuff is tenacious. Get a pen and make some marks. All right, here goes nothing. I got some marks right under where I think the relay is. I'll just go at it with a razor blade, being very careful. As AVE would say, apparatus predates safety. Even if I do cut this out, I'm still expecting a fight. I hit that area with the heat gun just to soften the plastic a little bit. Well, that softened it, all right. Wow. Amazing how well heat guns work. Obviously don't want to cut into the back of the board. Man, this is intense. There we go. I think we're through it now. It feels like I'm inside that coating. A little bit more. Success. Smells lovely. And I was right, there is potting on the bottom too. We never would have gotten this out, there's no way. Now we just have to cut through that and take the relay out. That's gonna be fun. I decided to open things up a little bit more. You can kind of see the relay contactors, one there, and hidden there, and there. It looks like 4 total. So we got to dig out those solder joints, and then we got to dig out around the relay, and then use our solder sucker to remove the solder, and hopefully this relay comes out without too much of a fight. Again, we got nothing to lose. So I got that dug out kind of as best I can without damaging anything. Hopefully not damage anything. I'm going to hit that with some 99% pure alcohol, see if it dissolves any of the remaining residue. Not optimistic, but we'll give it a try. 99% pure isopropyl rubbing alcohol. Focus, come on. There we go. Again, doubtful, but it's not going to hurt anything, that's for sure. Let that sit there for a while. Maybe now that we have a kind of a clear lens into what we're working on, maybe I can take a pick and kind of work at it a little bit more closely. Hopefully, again, without damaging anything. Okay, I let it sit with alcohol for a while. It did clean things up a little bit. I go to the soldering station and see if I can melt any of these contacts. I'll leave you guys here for now. After a lot of fighting, I think I'm starting to get some separation between the relay and the board. It's starting to pop up now. In fact, it might be out now. Cool. Got the relay out. Man, what a bear. So now the challenge is to find this relay. Zoom, focus. There we go. Find that relay in the midst of an electronics shortage. Let's see what we can find. Okay, it's like maybe 2 or 3 weeks later, and I was finally able to get one of these relays. It is by TE Connectivity. It's an OM, or maybe a 0, one of those two, OMIH SH112LM. DigiKey has them, they're about $2 a piece. They were out of stock for quite some time, and I was checking daily and checking, and then finally one day they had 953 of them in stock. So I ordered 4 of them, just in case I ever encounter this washer again, or a similar problem like this again. I mean, odds are I'll probably never use them, but hey, they were $2. So now the next step is to simply install this relay where we took the old one out of. So if we look at the control board, we just need to solder this right there. So we'll flip this over, we'll stick it on the soldering station and put some solder there. I'm not going to show you guys that part only because it's a little tedious, and I usually do this under, well, maybe I will show you. What the hell. Soldering iron is warming up, so this is the first leg of that relay that we're going to hit with some solder. Looks like the soldering iron is all warmed up. Let's see if I can do this without bouncing around all over the place. There's the solder. Just give it a minute to soak in. That one's done. So you just got to do the remaining contacts just like that. Got all 4 terminals soldered just to give you guys a better view of the finished product. It's a little messy, a little dirty right now just because there's still flux on there. So that's kind of what you're going for. These little electronic microscopes are really a lifesaver sometimes. This one was super cheap. You could pick it up on Amazon. I think it was maybe, don't hold me to this, maybe around $100. I'll leave a link in the description. Alright, so I'm going to clean this up with some 99% pure isopropyl rubbing alcohol. Then I guess we'll repot it because if this doesn't work, not much we can do. The board's junk. Hit it with some compressed air, dry it off. And we'll let that sit for a couple minutes. Exactly a couple minutes later, I have this black epoxy potting compound that I have from another project. Comes in a little syringe here. Give you a link to this on Amazon too, but I don't think you really need this stuff. I just have it, so I'm going to use it. So I'm just going to use this to kind of finish things off and put things back in original condition. So I think it's more important that we pot this side because this is the side that's going to be facing upwards. So I'm just going to fill this whole cavity with this potting compound. I have no idea if it's chemically compatible with the stuff that's on there, but I guess we'll find out, won't we? This will protect it from moisture and all sorts of other lovely things. It's very gooey and disgusting though. It does take a while to level out. So let that sit, wait for it to cure, then we'll do the other side. Here's a free tip. A lot of times when you buy epoxy in a syringe like that, it comes with one of these mixing needles with these cavities that are kind of built into the needle. They only usually give you a 1 or 2, and that kind of makes the epoxy a one-use item. But what you can do if you want to clean this out, just take some compressed air gun, hook it onto this end, and just blow all the crap out of it. I've probably used this thing at least half a dozen times so far, and it still works just fine. So just take your compressed air gun, blow through the end where the epoxy comes out. Come on, focus. There we go. Blow your compressed air through this end here. Let all the snot come out that end, and then you can reuse it as many times as you want. Okay, it's been a couple days now. So I got that epoxy potting compound on the surface here. Here's the new part. You can flip it over. Got epoxy covering this repair area as well. So everything should be good to go at this point. So now it's just a matter of putting it back together, testing out to make sure it works, and hopefully there's nothing else wrong with this thing. Let's see if I can remember how this goes back together now. Is it like this? Or like this? Yeah, I think it was like this. Yeah, because these guys get hooked up here and here. All right, so let's pop this back together. Okay. This one's a little deformed here. Not much we can do about that. So Let's open the machine up. I think it goes back in like that, right? I think so. Let's get the screwdriver on there. Take those screws out. Anytime I'm working on something and I know I'm not going to get back to it right away, I always put the screws back where they came from, just so I don't have to fight my own memory to remember where things went. That has served me pretty well in life over the years. Now for a test, I think that washing machine hoses are the same threads as garden hoses. I might be able to wheel a garden hose in here to do our test, which would be preferable to wheeling this thing in my house. So let's put the computer like so, I think. Now, one of the nice things about this design is that right now you're looking at the underside. So all these components here are going to be on the bottom, so it's going to be almost impossible for water to get on them, which is, in my opinion, excellent, because you don't, even if they did get wet, you have all this potting compound, but still, it's an extra layer of protection. You don't want electronics to get wet. Yeah, I think that's how it's supposed to go. So we got a screw here. Unless, oh, maybe, you know what? I think this is supposed to fold in. Let's see. There are these little tabs here. I think we have to angle this computer in. Like, yeah, there we go. Let's take these screws out. Tabs I'm referring to are down in here. So you got to fold the computer, not fold, just kind of angle it in like that. That's how it goes. Now it sits nice and flat. It's a pretty sturdy design. Have to give LG some credit for that one. Alright, I think this is in well enough to be able to get this wiring harness back on. Put the remaining screws in later. So let's see. So, where did this go? Well, I'm guessing this had to go here, only because that's where it seems to reach. Yeah, I think this snapped in here, didn't it? Oh, you guys remember? I don't know what it's for, but it looks like where it goes. So many wires. Hey, it'll either work or it'll let the smoke out, right? Or not work. But I think that's kind of the same thing as letting the smoke out. Then we had these connectors here, like so. And that. And that. I think that's it, right? Got all the connectors back where they came from. Let's get that remaining screw and 2 screws in there. This is so exciting, guys. Pop that cable in there too. There we go. And this went on how? Boy, you got me. How did this go on? Yeah, I guess like that. And this screw looks like it has to, yeah, this screw's got to come out. I put this one in too soon. I should just look at the footage I recorded taking this thing apart, right? That'd be the smart thing to do. Because you guys already know how this came apart, because you just watched it. But that is way too smart. I like to do things the difficult way. Guess and check, baby. Okay. Metal housing is on. Check. Okay. Time. So now this. Oops. A piece of plastic fell out. Probably something that broke off. Okay. And this, I think, just slides back in, right? Yep, like so. And then these bad boys go in here. I'm realizing you guys probably aren't seeing that. There we go. Sorry about that. Almost the moment of truth, guys. Where's my electric screwdriver when I need one? All right, let's get a power cord. Okay, have your fire extinguishers ready. Hope your popcorn's made. I'm plugging it in. Okay, it has power. Let's press the power button and stand back. Ooh, that's a good sound, right? I don't hear a wash motor running, or a drain motor running. Is there a drain? Wow, this is complicated. Soil level. See what happens, right? Oh, I just turned it off. That was dumb of me. Do. Let's do. I don't know how to use this darn thing. What's DE mean? Did I do something wrong? DE. I don't know. A quick search on the interweb indicates that, like an idiot, I didn't close the door. Let's try that again. Indicated it wasn't able to lock the door. Let's try start. There we go. That's better, right? It's spinning. That's cool. I don't think we're ready for that. Okay, unlock the door. There we go. All right, I think now that it seems to be booting up and doing things that seem somewhat useful, it's time to hook it up to a garden hose and see if it does things that are really useful. Okay, I got a garden hose hooked up to the back of the washing machine with one of the leftover hoses. So let's try this again. I got power applied too, so we got water and electricity, which is perfect. Let's see if it actually fills with the water and does something useful. Start. So it's spinning inside. Actually, let's do a cold water. Wash temp, power off. Sorry guys, I really don't know how to use this machine. You can probably tell. Special use maybe? Cold, there we go. Start. So all we got is cold water. It's kind of twitching around in there. Hopefully that's a good thing. Oh look, a rainbow. You guys can see that. Wow, very pretty. It's spinning real fast. Hopefully it fills with water soon. Still load sensing. Oh, now it just switched to wash. Oh, we're filling with water. That's cool. I think it's working, boys and girls. The test will be, will it drain when it's told to? The water started pouring out the back just because I didn't have a drain hose hooked up, so I just stuffed a rag in there for now. It's a mixing. Rather than waiting an hour for this thing to finish a cycle, let's try canceling this cycle, because I know on a lot of units that will force it to drain. Is there a cancel button? Man, I should have read the manual. Signal on off. What does that mean? No. Let's try pause. So I guess that means I can go in there and look around. Okay. So now if I hit power off, will that trigger the drain? Apparently it will. Okay. How do you drain? Special use soak, fabric softener, rinse, spin only. Maybe that? So now hopefully this thing will start spinning. And, whoop, there it goes. It's a running. Just spat the rag out. Drain motor is running. Very cool. This washing machine's fixed. Okay, drain motor is still on, and it's still in a spin cycle. Let's make sure it actually goes off, because that was the problem when we first got it, right? Those relay contacts were sticking, you turn the machine on, it would drain. So it's still on, but kicking out very little water. Let's turn it off. And it did stop. Lid is open. Let's turn it back on and tell it to start a cycle and see if the drain motor comes back on. I don't hear it running. So we are not having the same problem that we were having when we got this machine. So I think that relay fixed it. Anyway, so I've never done this repair before, but you guys saw how a $2 part brought down probably what's a $500–600 machine. That control board that I was repairing, we could have replaced that whole control board to the tune of $150 to $200, but as you can see, with a little bit of elbow grease and a couple parts from DigiKey, or actually a single part from DigiKey, I just happened to order multiples, we fixed this $500–600 washing machine for $2. So anyway, I hope this video helps somebody. If you liked the video, please subscribe, stay safe, and thanks for watching, everybody. Take care.